Here we will discuss a question that was given to the fifth graders during the second round of the Singapore's National Maths Olympiad in 2017. It's a travel speed and distance problem. Okay, here is a question. George and Heidi were jogging at different uniform speeds on a route AB towards each other from points A and B respectively. When they first met each other, they were 64 meters away from point A. When they each reached points B and A respectively, they turned around and jogged back towards their starting points. They met each other the second time at a distance of 168 meters away from point A. What was the distance in meters of the jogging route AB? Okay, before solving this question, we have to understand that this is a word problem, and the best way to solve word problems is to break it down into a simplified diagram. Let's start by doing this. Okay, here is a route A and B. Here is George and Heidi in red and blue. They start jogging toward each other and meet 64 meters away from point A. They continue jogging, reach the opposite ends of the route, turn back, and then meet for the second time 168 meters from point A. And the question is asking to find the distance between A and B. Okay, let's see what happens at the first meeting point. At the first meeting point, George travels towards the first meeting point. George travels 64 meters, and let's say it takes him a time of t1 to travel this distance. So his velocity or his speed would be distance over time, which is 64 meters divided by t1. For Heidi, the distance now would be this distance, which is d minus 64. And she will travel for exactly the same amount of time because they start at the same time point, and then at the point where they meet first, they've traveled the same amount of time. So the velocity would be just d minus 64 over t1. Now let's take the ratio of their velocities. Then we end up with the equation of this form where t1s cancel out. So times they traveled is becoming irrelevant for this equation. Now let's consider the second meeting point. At the second meeting point, now George travels from A to B and back. So he travels distance d first and turns back from point B and travels a distance of d minus 168 meters. And let's say it takes time of t2 to go from A to B towards the second meeting point. So your time is t2. So the velocity is just the ratio of the distance to the time it takes. We open up the bracket, then we have 2d minus 168 over t2, or if you factor out 2, then we'll just end up with 2 times d minus 84 inside the parenthesis divided by t2. Let's do the same thing for the Heidi. Heidi travels distance d, turns back, and travels at this another 168 meters. So her velocity would be d plus 168 divided same amount of time as George, which is t2. Now again, I'm going to take the ratio of their velocity, and we end up with the equation in the form of equation 2. And again, we see that time is irrelevant, cancels out, right? In both cases, in the equation 1 and equation 2. Now, since they're traveling with this constant speeds, we can set the right-hand side of this equation 1 and equation 2 are equal to each other because the ratios should be the same. And we obtain this equation by just dividing the numerators of this equation by 2. We obtain a slightly simplified version of this equation. And what we do, we cross multiply to obtain this equation, right? So d32 times d plus 168 and d minus 64 times d minus 84. Now, let's multiply it through by opening up the brackets. And what do we have is 32d plus 32 times 168 equals, just opening up this d squared minus 84d minus 64d plus 84 times 64. Now, keep in mind that this 84 times 64 is the same as 32 and 168, because 168 is nothing but 2 times 84. If you have 2 times 84, then if you multiply 2 with the 32, you're going to get 64, right? So these values are the same, so we can get rid of them, cancel out, or subtract from both sides, and we obtain a slightly simplified version of the equations, and we move by moving 32d to the right-hand side, we end up with this equation. Now let's combine all of these together, and we have equation in this form. Now I can factor out d here, and what do I get? I get 0 equals to d times d minus 180. Now this is a product of two numbers. For the product of two numbers to be equal to 0, one of those numbers have to be equal to 0. So either d is 0 or d minus 180 is equal to 0. So we have two solutions. Either distance between point A, B is 0 meters or it's 180 meters. But distance cannot be 0 meters because we already know from A to the second meeting point is 168 meters. So it has to be at least bigger than this number. So the first answer we can just ignore, and we only left with D equals 180 meters. I hope this was clear to everyone. And if it is not, please leave the comments below the video, and I will either try to explain below your comments or generate another video that digs into the details of this type of problems in a more comprehensive manner. Thank you.